So this is a problem, and what they have mentioned is you're given a list of words. This is your input, and what you have to output is the words in this array.
Hey, you have not shared your screen.
Oh, I'm sorry. Are you able to see now?
Yeah.
Oh, sorry for that. So what we are given is a list of words, which is the input, and what we have to output is the words which can be spelled out or which can be typed in a single row of the keyboard. So suppose the element, the word hello. So for typing hello, we'll have to use H from the second row, E from the first row. So this should not be in our output. Whereas the other one, like Alaska, the entire word can be spelled out using characters in the second row, A, L, A, S, K, and A. So this should be in our output, similar to dad and then peace. So out of which you can see only Alaska and dad are the two words which can be spelled out. All of the characters in all of the characters in the word are in the same row of the keyboard. So that's what we have to do. Just find out which words can be typed using the characters in the same row, and that should come in our output, right? And from the node point, they have said even if you have multiple characters, you can consume them. They can be used. It's not necessary that you can use those characters only once. You can use them multiple times. Okay. So any approaches, ideas?
I solved this problem using hash maps. So I
Mm-hmm.
just created like for each character which row they belong to. Okay. So
Mm-hmm.
let's say QWERT. If for
Mm-hmm.
these entities in the hash map, I'd store 1. For
Mm-hmm.
ASTF, it's a constant space because I'm only storing all the alphabets. So that's a
Okay.
constant space requirement. And
Mm-hmm.
for each character, I'm checking like if like the first time if the hash map value changes, like if it's going 1 1 1 and then it moves to another, then I break it and I don't consider it as a valid word. But if all the characters are in the same hash like value of the app is same, then it's a valid word that we can type in the same row.
So right.
The time complexity would be like the maximum of characters into n words. So whatever the length of the maximum string is into the number of words.
Right. So you're essentially taking the constant space complexity because the number of characters in the keyboard are very, limited. It's always going to be
Yeah,
same. Right.
yeah.
So one question: do you need a hash map, or you can do it with some other data set like a hash set?
Yeah, has that like uh
Right. So
yeah,
why do we need a hash set? And so essentially the question is when do we need a hash map and when do we need a hash set?
those are I guess ordered in some way. Like in hash set, the elements stored are ordered in some way. So I think searching would be faster, I guess.
No, both hash set and hash map will have the same internal saving structure. It's
Okay.
just that hash map is usually used when you have some additional information to be stored corresponding to that key, right? Here, if you create three different arrays or three different sets, you can directly find out the first one, second, and third one, right? You don't need
Yeah.
essentially anything additional. Like there's no frequency of characters or there's no position of characters that you want to attribute to each of the character. Like Q is first, W is second. So what you need essentially is just the characters which are in the set one.
Okay. Yeah, got it.
But how you know when you cross two different sets? Then you have to somehow keep track of what set you are currently in.
Right. So what you can do is just take first character okay, and find out of 3 which set is in. Suppose it's set 2, and always try to find all the other characters in set 2 only. So if they fall in that set 2 only, you are still in the valid word. If you cannot find that character in the set 2, it's not a valid word, right? That's what the problem says. All of your characters should be in the same set or same row.
The input is only have the character only, right? No number and no.
No, so it's later on. You may assume the input will only contain that.
Okay.
Even if it's a number or something else, it will just increase the space from 26 character to a 256 ASCII byte, right? The number of rows in the keyboard will already remain same. There will be 4 or 5 maximum rows.
Yeah. So if that's the case, we only need 2 sets. We don't need 3 sets.
Sorry, why do you need 2 sets?
I mean, 3 rows, right? So, if you only need 2 sets, that means, either in set 1 or set 2, otherwise it have to be in set 3. I mean, you implicit,
So
you don't need
in
it
that case,
explicitly.
okay. So in that case, if the element is in third set, you will have to always compare, values in both the sets. You'll have to compare, suppose you get a first character as Z, it's not in set 1, not in set 2. Now for any other character that comes in the word, you'll have to always check whether that falls into both of the sets. Both of the sets are there. If it does not, then that's correct. So it's just, adding one more comparator, even though it will not matter from the time complexity point of view. It will essentially reduce some space, but we are essentially talking about very constant space. So it will not matter that much.
Yeah. So the other way I can think a different data structure is using a constant array. So this only 26 character, right? So each character we map to, let's see, row 0 or row 1 or row 2, right? So we keep track of what row we currently in.
Right. That's exactly the approach I think we started with. The only difference was we started with the hash map, but yes, in hash maps and all, they have some internal overheads which arrays can optimize. So probably yes, we can go ahead with arrays, to define our positions like Q, A, and all. They can be represented as indexes in a simple 26, position.
One doubt that I had, like regarding the approach using arrays or hash sets versus hash map, was like, if I want to check, let's say, a character in the given string, if it exists in the set or not. So the time complexity of checking if a element contains would be a logarithmic type, right? For a set.
So sets and hash maps from the key point of view work very similarly, right?
Yeah.
Asymptotically, you can consider they have a constant time, right?
Okay.
Because of the hashing mechanism that is used. If it's a really unique hashing mechanism, it's constant time. But if you have any clashes, hash collisions, then only it increases. So from a normalized point of view, from a asymptotic point of view, we can look all the lookups in a hash map as constant time.
Okay, so it won't affect like whether I use a hash map or a hash set.
Right. So hash map and hash set, from the key perspective, they both work similarly.
Okay.
What about the difference between set and a list?
Sorry, could you repeat again?
The difference between if I use a list instead of a set, array list.
How will you look up in an array list?
List
And
dot
what will be the time?
contains.
Right. And what is the time complexity for that?
I think the elements that are present, I'm not sure about. I think it should be the number of elements.
Right. So that is in linear time, right? And from hash, what we get profit is having a constant time.
Oh, okay. I thought even for set, you have to go through the entire set, or no?
No, so the hashes, hash maps, and hash sets work in a way. So they take all the keys, convert it into some sort of a hash, and internally, what they do is some sort of bucketing, where they can put the values there, and kind of map it to very internal, specific location-based things. Like they know that this key will be in some specific bucket, and then they try to search in that only bucket, right? That bucketing, there are multiple ways of implementing hashing. I would suggest go to some site and just look at how the hashing works. There are different approaches. So kind of, if you, that's what I'm saying, in worst case scenario you will have collisions in a hash map where the same key internally will refer to multiple locations, but from the user point of view you can look at hash maps as a constant time. That's the main use of, that's the main difference between a hash map and an array. The arrays, if you want to find anything, you'll have to either use indexes or search through the entire array. Whereas in case of hash maps, sets, you get that constant time lookup using the keys.
Okay, sounds good. Thank you.
Anything else?
I think we can move on to the second question.